All right, so it looks like we are live now.
That's good.
So does that mean it's being recorded then, or does that just mean we're live?
It's being recorded now.
Oh, okay.
So the first thing I noticed was in the lesson 4 preparation assignment, questions 5 and 6, it said to do in the group meeting.
Question 5 and 6, yes, it's in a group meeting.
Yes, so I guess we can just go ahead and talk about those.
I kind of missed that part and just did it.
Yeah, I did it too, but
Which one?
Question.
So, yeah, question 5 and 6.
Oh, your group meeting quiz?
No, it's on
the preparation assignment.
Oh, preparation, okay.
Yeah.
So what let's outline a plan. What are we doing? Group meeting quiz or a quiz has to be done separately? What's happening?
So I think we can discuss the quiz together, but we each input the answers to the quiz.
Oh, okay.
We will, yeah. We should do just talk about questions 5 and 6, and then we'll go in and one of us can, we can bring up the quiz and then we can talk about each, but we each put in our own answers on the quiz, but we do it together.
Right, yeah.
So.
Okay,
so go ahead.
No, it's fine.
All right, well, for question 5, it says an 8-sided die has 8 possible outcomes for each roll. Calculate the probability of rolling a number greater than 5. So I got 3 8s or 37.5%.
Yeah.
Okay. The 8-sided die has 8 possible outcomes. So there are 8 possible. In this event, you got 8 outcomes. Okay.
Right.
Now, we asked to calculate the probability of rolling a number greater than 5. What are the chances that we can have numbers that are greater than 5? How many numbers are greater than 5? How many numbers we got greater than 5?
Oh, 3.
There are 3.
Yep.
Yeah, so 3.
Yep.
Okay, and each of them, the probability is equal to, chances for them to appear is 1/8. So
right.
1/8 and 3, or 1/8 plus 1/8 plus 1/8, 3/8, correct?
Right.
Yes.
That's correct. Now, number 6, calculate the probability of not getting a number greater than 5. And you remember one of the rule in probability says that the probability of getting a number not greater than 5 will be 1 minus probability of getting a number that is greater than 5. So it will be 1 minus 3/8. Correct?
Right.
So which is, when we calculate, will be 8 to a numerator, 8 minus 3, it's 5/8.
Yep, that's what I got.
Yeah. So otherwise, it's a probability of getting 1, 2, 3, 4, and 5 altogether.
Yeah.
Yeah. Okay.
I think we all understand that one.
Yeah. That's good.
Do you mind me asking one question here? What have you guys done as far as past math?
Just college algebra is the highest I've gone, so.
Okay.
Can you repeat your question again?
What other math? What is the other math classes that you've had? Or the high?
I've had FD Math 108. I did that one, and then I got also got Math. Was it 102 or something? Then, but that many probability classes some 20 years ago.
Yeah.
Statistic, probability, that's long term.
Sometimes
refreshing your mind and trying to understand better.
Okay. I was just trying. I was thinking I should probably get an idea of where you guys have been at in relation to what I love math. So
I also love math. So we're gonna have good fun here.
Yes.
I would say I like math. I don't love it though.
Oh, I love it. I make my kids do math in the car, and I've had kids on the school bus. They want me to give them math problems. Like, works for me. So, okay. So sounds pretty easy. We all understand that one really well. Should we just go on to the quiz?
Yeah, let's do the quiz.
Okay, let's go to a quiz. But as you go to a quiz, let's say catch up on probability. And speak of, I think in the quiz you will see word like proportion. There's not big difference between proportion and the probability. It kind of sounds the same. Correct?
Yeah.
Yeah. Okay, if we can go there now. Quiz number 1.
Yeah. Lesson 4, group quiz meeting 1. All right.
Okay, 1. We completed, yes, it's fine. We'll do it later. Now, question start with number 3, I guess.
Yes.
I think when we're all done here, I'm finally going to go get something to eat. I just realized I haven't had breakfast yet.
Oh man, lunchtime.
Yeah, it is.
I had dinner already. My stomach is full. It's a 9:12 here down South Africa.
Yeah, that's right. Well, you can have breakfast for dinner, right? Yeah.
Maybe I don't know. I will see. Breakfast, yeah, before I sleep, or take some fruit. Okay, now the question says, the blood types and the proportion given in a table above define a probability distribution. Now the question is, it true or false?
I said it was true because all of the probabilities add up to 1.
Okay, that's correct. That's what I saw also. It's true. Do you agree, Crystal?
Oh, I was reading it. You guys got ahead of me too quick. I was still. So as long as they add up to 1, I'm happy.
Yeah, they do.
Yeah, so they meet the probability rule. Yeah,
okay.
Rule number 2.
Alrighty.
Now, question 4. Crystal, can you read question number 4?
What is the probability that a randomly selected person in the U.S. has type O blood?
What is your answer?
What is the probability? Hang on here. It says 0.45.
That's correct.
What I got.
That's correct. And
okay.
Then question number 5.
What is the probability that a randomly selected person will not have type O blood? That would be 0.55.
Oh, how did you get it?
I just did the 1 minus 0.45, so.
That's correct. That's correct.
Yep.
Question 6. If a dog guess at random, what is the probability? Okay. You got Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle one of the dogs demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the sample were from patients who did not have bladder cancer. 1 of the sample came from a person identified as a bladder cancer patient. Our question is, if a dog guess at random, what is the probability that they will correctly identify the dish containing a specimen from a bladder cancer patient. The answer is 0.143.
Yeah, that's what I got.
What's that?
Got it, Kristen?
Wait a minute. It says, what is the probability that they will correctly identify the dish containing the specimen? How? And they have 7? Oh, that's what I did wrong.
Got it?
Wait, 1. And you guys said 0.143, correct?
Yeah.
Okay.
Yes.
Yeah. Yep, that's what I have.
You got it?
Yeah.
That's correct. Number 7.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patients 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There's little evidence that they can't, that dogs can detect. And I would say this provides strong evidence that dogs can detect.
Yeah, I agree.
Yes, I agree also. Why?
Why?
Mm-hmm.
Because it's unlikely that they randomly would have chosen that, got it right that many times.
Yeah. So it's correct. They provide a strong evidence. Question number 8.
See, if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? That one's just 0.13, it looks like.
Yep, it's right there. 0.13.
Okay. That's interesting. They crossed out green. I guess they're going to have us figure it.
I know, better start working on it.
Oh, gee, the next question. What is
Figure it out. Crystal, it's yours.
Yeah. Oh, that's actually the next question. What is the probability that a randomly selected candy is green?
Yeah, with bearing in mind that the probability of all the events is equal to 1. So you get how do you deduct the answer?
I get 0.16.
Yeah, that's what I get.
That's correct, 0.16. Now, what is the probability that a randomly selected candy is not green? And of course, it will be 1 minus 0.6. 16 is 0.84.
Yep, that's what I got.
Yeah,
Yep.
0.84. London, next question.
Half of the observations are less than or equal to what number? This is a review, so that would be the median number, which is 24.
Okay, that's correct. The median number, 24.
Yep.
Now, Crystal, number 12.
Based on the information on the table above, the top 25% of the students scored above what number? And that would be above 27.
That's
Yep.
correct. That will be a Q above Q3.
Yep.
Is 27. That's the last portion of 25%. The maximum is 35, huh? What is the maximum?
What's that?
The maximum of
Oh, 35.
35. So 27, that's the answer. The last one. Which of the following statement is not one of the three rules of probability? Okay, the first one, probability that an outcome will not occur, 1 minus probability that it will occur. That's correct. Probability is a number between 0 and 1. It's correct. It can be less than 0 or more than 1. It's correct. The sum of probability, any probability is 1. It's correct, which means the third one is wrong.
Yep,
If
that's one I got too.
higher, okay, the third one is wrong. That's good. So are we all satisfied?
Yeah, I am.
Yeah, I think they're all correct.
Okay.
100%.
All right. Well, I will stop this recording and then
Okay.
I'll send another invite to a different recording for lesson 5.
Okay, that's good.
Okay.
All right. See you in a minute.